Okay, so I'd like to talk about rigid diaphragm constraints for 3D models in OpenSees. All right, so what we have here is a water tower model from a paper by Bjornsson and Krishnan from 2014 in the journal Structural Engineering, and we're using this model in our nonlinear structural analysis class at OSU. Okay, so the model is shown here, right? So this, elevation, but the water tank is up here. There's a floor and there's a roof, all right? And then the plan of the floor and the roof is shown here, okay? So, X is this direction, Y is this direction, and then Z is the vertical, okay? So there's 1, 2, 3, 4 columns or nodes in the interior, and then 8, 1, 2, 3, 4, 5, 6, 7, 8 columns or vertical members on the exterior. All right. And if you look in the paper by Bjornsson and Krishnan, they use elastic shell elements for the floor and the roof. Okay. But I don't want to do that. I just want to make a rigid diaphragm. Okay. Instead of defining shell elements. All right, so first I want to look at, what happens when we do not include rigid diaphragms or shell elements at all. Okay, so this is a plot of the model within OpenSees. Okay, and you can see, there's nothing, connecting those braced frames, in the top of or in the water tank. Okay, so if we, define some mass, or excuse me, some gravity loads, all right, as well as mass, as described in the paper, right, and then do an eigenvalue analysis, right, we'll look at the modes or the mode shapes and see, by leaving out shell elements and rigid diaphragms, things get pretty weird, all right, which you would expect, right? Okay, so we'll start at the top. I did spit out 6 modes here, but mode 1, all right, is flexure about the global or in the y direction as you would expect. All right, that looks fine. All right, mode 2, symmetric structure, so it's the same thing happening in the orthogonal direction, along the x-axis. Mode 3 is torsion. Okay, but you can see there's some distortion within the top of the tank, right? Because we don't have the constraints in force or rigid diaphragm or shell elements or anything. Mode 4, gets pretty bizarre looking mode shape. All right, and that's again, because of the lack of constraints. And then 5 and 6, are equally as bizarre looking. I have amplification factor here of like 1,000, right, on the mode shape, but just highlights uh, what happens when you don't have the constraints. Okay, so clearly we need something, right? So, in lieu of doing shell elements, right, I'm going to make a rigid diaphragm by first for the floor of the tank, defining an extra node in the center. All right, so define a node right here at the center. All right, call that node 600. All right, and then fix the Z translation and X and Y rotations for that node, right? Because we don't want, we want this to move as a rigid diaphragm within the XY plane, all right? So, vertical motion of that node, i.e. up and down right here, as well as rotations about the X and Y axis, we want to fix those, all right? And then our rigid diaphragm is going to constrain these 12 nodes, 601, 602, 3, 4, and then 605, 606 through 60 or 612, all right, to be controlled by this primary node here, okay, which is node 600. Okay, they'll all move in the x direction and y direction together and then rotate about the z-axis, as a rigid diaphragm. Okay, so to that end, right, we say this is the control node, and then these are all the secondary nodes that will be controlled by node 600, right? And then the 3 here indicates the perpendicular direction which means Z is the perpendicular direction to the plane, or perpendicular to the plane formed by those nodes. Okay, right? So, X is 1, Y is 2, and then Z is 3. All right, so coming out of, or coming up here, or coming out of the screen right here. Okay, that just tells us how to constrain the motion of those nodes to node 600. All right, and then we do the same thing for the roof of the tank. All right, this is 701, 2, 3, 4, and then 705, 706, 707 to 712. All right, to find another node 700 at the middle, right here. All right, and then uh, fix the degrees of freedom, and then use the rigid diaphragm constraint to make this the control node, and then these the secondary nodes. All right, that'll move as a in unison with node 700. Okay, so when we go back down here and plot the model, right, just rerun everything above. Right, the model looks the same, right? We didn't add any elements or anything. We just added a node, which you don't see, all right? And then when we define the gravity load, mass, and then do the eigenvalue analysis, right? We look at all the 6 modes again. You see that the modes 1 and 2 remain the same. The period changes a little bit, right? Because we've stiffened up the structure by adding these constraints, all right? But X and Y flexure, right? And then torsion, right? You see that the tank remain fairly straight, but you can see there's a little bit of torsion between the floor and the roof, all right, or twisting, right? And then mode 4, which looked pretty odd without any constraints, all right, it looks a little more reasonable, right? It's basically squashing or extension uh, of the water tower. Okay, it's just moving, this part is just moving straight up, all right, from the dash line to the solid line. Okay, all right, but again, there's no, distortion within the tank. All right, and then mode 5 and 6, all right, are, severe flexural mode. All right, but again, you see that the floor and the roof of the tank, aren't distorting. Okay, and same thing here with the in the orthogonal direction from the previous mode. Okay, so it looks a lot more physically reasonable. Again, I didn't want to have to define shell elements, all right, but just enforcing rigid diaphragm constraints. All right, so I hope that made sense and showed the effect of rigid diaphragms, and it's pretty easy to define those within OpenSees. Okay, so thank you for watching.